So we have here this epoch that is equals to this epoch. So the validator psi, that's a validator index. We have a validator index. So this condition of self you need to return the epoch. So far, this epoch, you can find here that this epoch have different supermajority, and the supermajority is terminology that BFT protocols means that you need to have a justificate chain that it's the correct way for reach the consensus. So you need to expect this kind of connection between the beacon state and the shard chains, and remember that you have different shard chains, so it's the wave that needs to make no a trivial thing, so you need to make the not trivial things here. So it's a kind of rule. So let's move to see this create Spock validator index. So you have self epoch validator index, self validator index, then another decorator for here. Remember that in Python all are objects, so this self you need to return this. Then self condition of this, you have this class, the name, so you finalize. So let's move to see more signal voluntary exit. So far we saw here that this voluntary exit requires the epoch and the validator exit for make this voluntary exit. So you need to create this object for make this voluntary exit a success thing. So this signal voluntary exit, so type var of this condition voluntary exit. So you need to bound this voluntary So you have this class here also. Let's see, voluntary exit. So this hashable container will have fields. You have measures, voluntary exit, then signature process. You import this byte, so you need this byte for this voluntary exit. So let's class method if create CLS time this signed voluntary exit need to debugging this, so the message will be I don't want to go more in this chain, so let's move for here. So you need to signature this for make an extra thing, and the way that you need to sync this is with this BLS signature. That it's the new way for seeing all in this protocol. You have empty signature, so this thing and signature voluntary exits. So you need to return all the things, all the objects that you have here. So create this message, and the signature. So you finally do a voluntary exit of this supermajority for connect the beacon state with the shard chains in the way that voluntary exit for make another success connection with another epoch. So it's a thing that not properly needs to be recursively, so it's only a function that needs to make make a voluntary exit for create another instance for connect the beacon state with the shard chain. So far we saw here in this protocol specification about this beacon state and this beacon chain. I have these beacon blocks that make this beacon operation that are attestation operation, and basically it's way to connect a beacon chain with the shard chains that we saw in another videos, the algorithm for this attestation. So let's move to more things here. So let's to see this checkpointing. So what is the checkpoint here? So the checkpoint is let's see this simulation. Oh, sorry. So let's refresh this page and see the simulation. So you have here the beacon state, that is the genesis state. You have this genesis state of the beacon state. You have also the genesis state of the shard chains. So this beacon start to grow and grow and grow with parameterizer thing. You also have the shard chains and the crosslink that start to make this magic for number attestation that is connect with the POC, because this connection with the crosslinks are random. I have this beacon randomness that have the random plus the BDF thing in the phase 2, then in the phase when the phase 0 finalize, you have the random reveal, that is the output of this random thing for connect the condition that you have. So far, this crosslink attestation thing it's a new way for finalize the block. So under the hood is interesting way for handle this. So let's see when the checkpoint occur in the Python script. So this will be a class of this checkpoint. So this hashable container have these fields. Have epoch, have int, and also you need the root and device of this condition. You also need the class method decorating thing, so you need to create this object. So you have the CLS for type, this condition, and this checkpoint needs the epoch, and the epoch it's a default epoch that, remember, is a randomness epoch and randomness slot in the protocol specification. On the root of this, it's equals of 0 root. You also have here the checkpoint function. Return and create this epoch and the root. Then you analyze this object, then it return so you need humanize hash. This humanize hash is the hash that in the hardware implementation work. So it's self root finalize here. So default checkpoint, it's equals to new checkpoint, create this function. And so far this is the checkpoint that have to reach the epoch, that is a default epoch, and also you need the root for this. So the checkpoint needs to create this epoch object, and this object needs the humanized hash that basically it's the hardware implementation that needs for reach this checkpoint. So all is random, so you have to figure out a lot of things here for the epoch. So let's move to another thing for the protocol specification. So you have the previous justified checkpoint, that is a snapshot of this epoch, have this previous epoch snapshot You also have the current justificate checkpoint and the finalize checkpoint. So the finality of this need a vector, a bit vector of this. That is interesting way for see this. So let's move to see another thing here about this checkpoint. Could be the defaults of this. So this default, it's the BLS signature. That is a way for reach this. So let's see this default. So you have here all the data that you have. So you need the default bit field. So the bit field is the input for make all these things. You have also the default epoch. So let's see the default epoch for understand more things here. So all these things, you have also the default epoch. So let's see the default epoch for understand. So you have here the default epoch. In this way is for import this, and you have here for create the finalize epoch, that it's the finalize checkpoint. You also have here a clock condition that it's in the validator client, side of the validator client, and have this protocol specification that needs to be a 1. That is a synchronous decorator for waiting for Genesis, and needs to be this condition needs to be 1. You also the default epoch info that it's equals to epoch info. You also has this. Also is the default epoch. Epoch is equals to a default epoch. So you have here the default epoch. Here for import the defaults, and the defaults have this default BLST pub key for the empty pub key, and it's a default tuple. And this default tuple have sub element, so it's a way for debugging here. So it's incredible way that Python do. And we have here more default epoch. So you have the previous version, that is a default version, and the current version. So this epoch will be a default epoch also. So this is the condition of the finality of this beacon state. That is a container that have a lot of protocol specification and a lot of function here for works. So let's move to see more things here. Validator side of the default epoch. So you can see that this default epoch is in forks, the clock of the validator side. You also is a measures, that is the default pop that have the property of have equals to 1 or the lock ahead. So the default epoch is equals to epoch that emulates 0 types. That is a condition that has Python. So you also have in the typing the bit field, that's a sequence of these elements that have a condition of lambda, and it's all about this commit index. So far we saw in this protocol specification on the finality of these things, that it's a thing that could be for the phase 2 of analyze the beacon state, and so far it's still in development, so you need a lot of things for understand this and figuring out a lot of things also. So see you in the next video. See you tomorrow. Have a nice